A singular new design, a re-engineered system, the finest and the most sustainable materials. This is the thermal fluidine. The sun's thermal heat is used to heat a copper plate in contact with the thermoelectric peltier and works on the Seebeck effect, which causes the hotter electrons to move to the colder side, generating electricity. It's combined with a backup circuit, a heat dissipating heatsink for achieving the colder Peltier side, and a hollow casing to float on water. The internal mechanism has also been redesigned to maximize durability and allow for a new efficiency level using precision machinery and an intricate structure to produce 10 kilowatt hours per day. The world's smallest power plant just got better as it is now modular and can be connected with numerous modules at once in an array, all made possible with the hollow casing. The electricity can be drained using a 4-pin GX16 power cable. The new thermal floater is powered by the fundamental qualities of the 241 coupled thermoelectric Peltier. All this and more make the thermal floater the most efficient power plant ever. Today, the world still heavily relies on fossil fuels and even continues subsidizing them. Meanwhile, the pollution they cause, from climate damaging greenhouse gases to health endangering particles, has reached record levels. The land requirement for installing renewable energy power generation like thermal, solar, and wind farms is enormous, and for a large power facility, the condition is much more significant. In many countries like Japan, Singapore, and India, the land resource is scarce and a premium cost is attached even for a tiny piece of land. To solve the renewable energy dilemma, I propose a device that efficiently converts the thermal energy from the sun into electrical energy while still keeping a small form factor. The key partners here would be the power facility grids and utilities, institutions, governments and investors, and project based partners to help achieve the key activities and deliver customer value. Our vision would be to spread green and renewable energy throughout the world by the end of decade by building a global network and creating momentum. The product would appeal to targeted customers, the power utilities, the governments, institutions, and private developers. It can also be useful for generating electricity in remote parts or military bases, research bases, and islands where delivering electricity is highly expensive, and producing electricity locally can have detrimental effects on the environment. With floating thermal module installations, the evaporation from ponds, reservoirs, and lakes is reduced, and it also prevents blooming of freshwater algae. The price of individual thermal floater modules would be pretty low to be affordable even for the middle class people, which would allow us a large user base. The product would also be desirable to satisfy the existing users, leading others to buy it. It currently produces 3 times more energy than a typical solar panel in the same amount of area as compared to an available single solar panel that produces 300 watts per hour and 3 kilowatt hours per day. Therefore, the energy generated by an array of the same size of thermal floater modules will come out to be around 10 kilowatt hours per day, which puts it at a significant advantage as compared to the rest of the renewable technologies in the market. This has many other benefits as compared to the other competitors. It's more environmentally friendly as most of its materials are recyclable and non-toxic, and the materials used here are more durable than the materials used in the solar panels.